Line of best fit. A line of best fit is a straight line or a curved line, depending on what we're doing. We'll use a straight line that fits a set of data on a scatter plot. So we'll look at fitting a line just by eye, finding a predicted value from that graph, finding the equation of a line and using that value to get an equation. So there's a bunch of mathematical ways to fit a line to this, but you can see that, look, any straight line that's going to go through here should go roughly there. Your aim is to get the same number of points on each side of the line. Distance has a stronger pull, so if there's a cross down here, that would probably pull my line down. And using a ruler, and in fact a transparent ruler, is actually quite useful. So this one's pretty easy. If I place that there, I've got 2 lines above, 2 points above the line, 2 points below, 3 points on the line. And while this technically has 3 points below the line and 3 points above the line, this obviously does not work. So you want your line of best fit to have points evenly distributed along either side. Once you've positioned your ruler where you think it's looking good, place your line of best fit, and in fact my ruler was a little bit off there. Now the reason we'd want that is we're looking for some sort of ability to predict from this data. So if I had an x value of 8, what might I expect the y value to be? Now you can read that straight from a line, obviously. So when x is 8, we might expect y to be approximately, here's x is 8, take it across, 5.75. We are just estimating. Now we're outside the data that we sampled here. If I make a prediction outside the range of where my data points are, that is called extrapolation. Oops, extrapolation. And it is less useful and less trustable, we have less confidence in it, than if we are interpolating, which means making a prediction within the data set. So within this data set, I can be quite confident that an x value of 4.5 would give me somewhere around a y value of 3.5. There's a bit of variation, but not a lot. Outside this data set, I don't know what this does. It might continue in a straight line. It might be that this is actually the start of a curve and my data would look more like that. So the further outside your data set you go, the further out you're extrapolating and the less confident you can be about that estimation. Now we do also want to be able to find an equation of a line of best fit. We'll use this one. You want to find 2 points that are on the line. So we'll use this one and this one, but any of those 3 points would be fine. If the line crosses on a gradation, like if it crossed the x-axis or y-axis at a number, you could use that, but don't go trying to estimate this point here. So I have the points 1, 1 and 7, 5, and we do need to be able to find the equation of that line of best fit. So find the equation of the line passing through points 1, 1 and 7, 5. And if you remember from year 9, to get the equation of a line when you know 2 points, you need to find the gradient. Gradient is y2 minus y1 over x2 minus x1. Remember, label these. It doesn't matter which is point 1 and 2, but I've got x1, y1, x2, y2. Substitute them in. 5 minus, oops, sorry about that. y2 minus y1, 5 minus 1, x2 minus x1, 7 minus 1, I have 4/6, 2/3. So I've got a gradient of 2/3. Now, when you are finding the y-intercept, you have two options. If, as I said, you can clearly read your y-intercept from your graph, just read it from the graph. To get, however, a more accurate y-intercept, remember y equals mx plus b. Substitute in 1 point, make it the easy one, and the gradient, and solve gradient, and solve for b. So we'll substitute in 1, 1, because that's nice and easy. 1 equals 2/3 times 1, which is 2/3, plus b, so b equals 2/3. So I've got my y-intercept and my 1/3. Sorry. So I have my line y equals mx plus b, and the equation of that line will be y equals, the gradient is 2/3 x plus 1/3. Sorry, dropped my pen. So you can find the equation of a line of best fit. To find the value of that equation, of course, if I then asked you that same question, what is the value of y when x equals 8? I'll skip back over to my graph. I made the prediction of y equals 5.75. I could use y equals 2/3 x plus 1/3. Substitute in x equals 8. So y equals 2/3 of 8 plus 1/3. I really don't feel like doing that in my head today, so 2 times 8, obviously 16, divided by 3. Okay, yeah, fine, 5 1/3 plus 1/3. And so I've got 5 2/3. 5.67. I was pretty close with 5.75. Sorry, I chickened out and used the calculator. So, fitting a line of best fit by eye, using it from the graph to make a prediction, using the equation to make a prediction, and you can also do this in Excel. If you've made a scatter plot, somewhere in the menu will be the option to fit a trend line and to display its equation